Welcome to webinar 4. This is the final session on the program and project management, and we're going to look at understanding the main approaches to the control of major programs and projects. So this is all about control. 4.1 is approaches to strategic cost management, which is obviously a major issue in programs and projects. It's about how to analyse financial and management information. It's also about 4.3 analysing the impact of the supply chain that performance issues can have on programs and projects. So that's particularly contract problems, damages, problems with performance of suppliers. And 4.4 is closing out the project, how to obtain client acceptance, installing deliveries, project audits, etc. So specifically then, 4.1 is the actual approaches to managing costs. And we look at difference between fixed and variable price methods briefly, budgetary control and variance analysis, which is very, very important, value engineering, consortium-based procurement, and open book costing and cost transparency. So when we're looking at adjusting prices, we may link to some indices so that we can agree how the price might be adjusted. There are many indices about. There are indices on commodity prices, there are indices that measure inflation, and there are labour market indexes which track the weighted average of wages or salaries, and often these are used as a basis in contract price adjustment formula, or as a commonly known CPA. So if there's a mechanism in the contract to adjust the price, it's often based on the changing cost of labour and or goods at certain points in the contract. So indexation and price adjustment formula, a little more on this. To estimate current average prices or costs by using cost data for similar items, to eliminate the effects of inflation or deflation, to allow for currency fluctuations, to compare cost performance, and to identify average price cost changes as the basis for contract price or price adjustment calculations. So this is what we're trying to do. We're trying to come up with a fair price. It's not to adjust the prices for where they are at the end of the contract, but more on the average prices that the supplier would have incurred throughout the contract for labour and materials. So hence why we're talking about particular dates or average prices. So how do we deal with post-contract adjustments or increases? Well, they need to be authorised by a single person. Adjustments need to be confirmed in writing. Contract stakeholders should be notified of any agreed changes. If we're using standard costing, there should be a procedure for monitoring these adjustments. And where they're calculated in accordance with contract price adjustment formula, records should clearly indicate the cost base dates of the original contract and the circumstances that have given rise to the adjustment, the changes in the index numbers or indexes that you are linking to. Suppliers should be asked to provide data to justify price increases, and if they can't come to agreement, the buyer may need to consider alternative suppliers. So fairly straightforward methods then of dealing with price adjustments or increases. We would need to put in place budgetary control on any project. So budgetary control is very important in projects, and the purpose of it is to help us plan, to coordinate, to communicate, to motivate, to control, and to evaluate performance. They're strictly the benefits of budgets, but budgetary control is very much part of budgets. So there are many reasons why we have budgetary control. How do we set budgets? Well, we can have a top-down approach. The managers estimate. These cost estimates are passed down to lower managers who are provided with estimated costs, or bottom-up. People who are delivering it, schedule work breakdown are consulted, and the data's collated to get the total cost. So fairly straightforward, top-down, bottom. we need to build up costs. We need the material cost, the direct material, we need labour costs, and of course we'd need the overhead rates. Life cycle costing, very current in today's climate, is looking obviously at all costs, and we've got we've got service, oversee installation, select approval of suppliers, manage coordination, the delivery arrangement, price and communications are all part of the life cycle costing. That's not a popular schematic in the CIPS slides, isn't that one? Perhaps a more interesting one is lifetime costs of managing a capital asset, which is very much like the traditional total cost of ownership. There's the buy-in, the operating, the owning and the disposal. What we perhaps haven't got there is the pre-acquisition costs, which are often shown in total cost of ownership of assets. There can be unnecessary costs in projects, design, components, materials, poor buildability. It can be difficult for the contractors, unnecessary life cycle costs, maintenance after costs. So often in engineering construction contracts, value engineering will be carried out, but engineering is carried out at the design stage. Usually value analysis is not carried out because until the project is finished you can't really assess where you spent too much, and you may never repeat the project to take cost out. So it tends to be more value engineering on buildings than value analysis. So how do we do value engineering? We need the information phase, we need the speculation phase where we get the ideas together, we evaluate proposals, we develop the favoured solution. The presentation phase is concerned with the production of a report by the VE team detailing the conclusions of the study, and finally we implement the VE proposals. The PM should act on the proposals, indicating where the recommendations may be incorporated into the design, detailing cost and time implications. So really it's looking at how we can improve the design to improve the quality, reduce the cost, or reduce the time to build it. So value engineering, very important in construction contracts particular, but in all contracts. You can see the importance here on this slide, where the VE savings can be very high at the initial scope development stage, but it's very difficult to make savings as you go through the life cycle. And you can see the more complicated chart on the right hand side shows savings from VE as opposed to problems if you try and change things afterwards. So a little more theory on value analysis, value engineering. Definition of value: it's function divided by cost, or worth divided by cost, and the function is the capability plus performance. So we can increase value by reducing cost, but we can also increase value by improving the function, more usability, improving the quality of the project. And cost can also be defined in terms of cost, exchange, use and esteem value. So a useful slide there on value engineering. Strategic cost management is one way to achieve cost management, is to use consortium based procurement exercises, which can money, and there are benefits of buying alliances coming together. Economies of scale, reduced costs, shared intelligence, shared resources, investing together in supply development, increasing suppliers' interest costs greater value, presenting a united front to suppliers, releasing time to concentrate on more strategic procurement, and inter-member trading can be set up to cover for shortages. So some benefits there of buying alliances. And we can see there complication when we've got suppliers dealing with many purchasers and a whole range of relationships there. But consortium relationships simplify the number of relationships, where frameworks can be set up by the consortia, and the purchasers now only deal with the framework agreements which have been set up with the various suppliers. Difficulties though with consortium purchases: the central purchasing organisation that creates the consortium contracts will need to recover the costs of its personnel and overheads, and the difficulties gains achieved are automatically wiped out by the markup added to cover these. Maybe. It will rarely be the case the consortium contract will be mandatory. As a result, with organisations who develop purchasing, there can be a lack of buy-in to the frameworks. People might not use them, and there can be a lack of coordination amongst the members of a consortium, where a large buyer can tend to take control and be the dominant. Open book costing can be used, particularly when we're using incentive contracts. We will need to be able to monitor actual costs and verify these costs, so data will have to be provided on labour, material, hire costs, overheads, subcontract costs and even profit. And there's a template there for open costs, detailing breakdown of direct labour, direct materials, other costs, indirect, general overheads, with a overall total there to justify the cost that they're trying to recover. And now we're on to 4.2. 4.2 is analyse the use of financial and management information on the performance of major programmes and projects. And that very question has been asked before. Discuss three tools that can be used to analyse financial and management information. The unit content then is estimating budgets, measurement, monitoring, control and improvement, project tracking and control mechanisms, controlling variations, claims, etc., and implementing remedial actions. So how might we estimate a budget? Well, again, similar to 4.1, there's a top-down approach and there's a bottom-up approach. How do we measure progress? It could be percent complete, planned progress against actual. We could look at work in progress. We can look at impacts on critical paths, payment progress, work content, how much is outstanding as opposed to how much has been completed. Can be all used to gauge. Time controls can be on the budget, the overall project duration as fixed by the constraints in the contract strategy. The time plan, a division of total time into interlinked time allowances for readily identifiable activities with defined start and finish points. And time checking. It's slightly obtuse, that slide, but there are different control systems that measure time slightly differently, holistically, and down to activity levels. Benefits of having reports in project management: understanding of goals, awareness, better planning, understanding to relationships, early warning, reduced delays in communication and changes, faster management response, visibility, and keeping people up to date. So project reports, interim reports, progress reports all serve very useful purposes. Controls can be cybernetic, automatically detecting and correcting, like central heating. Go, no go, testing to see whether some condition has been met before you can go to the next step. Or you could have some post-control review after the event with a view to improving future performance. And we've got a typical project curve here showing cost against time, and if we're looking at, is this any good? Is the project running as it should? So the progress of it. So we might say, looking at this, that's very good because the cost to date is less than the planned cost. So you might say that project is progressing very well, but that doesn't tell you the whole picture, because you might have spent less because you haven't completed as many jobs as you should have done. So similarly, if you'd spent the cost was higher than planned, you might say, well, that's bad because you spent more than you planned, but it depends if you've done more or less jobs than you planned to do. So you cannot tell the progress of a project on cost alone or time alone. You need a combined measure, which is where the concept in project management of something we call earned value is used in projects to determine how well a project is progressing. Previous slide, we've got the actual cost, the earned value, and by measuring the distance we can see on this one the earned value is less than the planned value. So we've got a schedule variance and the actual cost is higher than the planned value. So there's some more terminology there: planned value, earned value, budget at completion, estimate at completion. So from these measurements we can also estimate the expected cost at the end, because we know what we've spent so far doing the jobs we have done, so we can use that as a basis for projecting forwards. So some definitions of those terms again, but there's a couple of new terms there. We can calculate the CPI, the SPI, and we can also estimate the project completion cost. So by measuring these first four things at any point in a project, we can calculate these last three, which give us some very important indicators. So here's an actual example showing the planned value, the earned value, and the actual cost. So what we've actually earned is $170, which was the $50 plus 80% of the $100 plus 20% of the $200, which is $170. The planned value we should have done is 50, and we should have finished the 100, and we should have finished half that, which is the 250. So we should have planned to earn 250, but the actual cost we've overrun there. We spent 60, we spent 110, we spent 30, we've spent 200. So we can see we've got variances throughout there, that the earned value is less than the planned value and the actual cost is higher than the earned value as well. So some poor figures in there, and we can see there if earned value is higher than planned value or actual cost, that's good. And we can also work out some indices. We can divide the EV by the PV, and if that's bigger than 1 we're doing better than we thought, and if EV divided by AC is greater than 1, that's also good. And that slide explains how the SV was calculated, so the CV, etc. So a worked example here, how to calculate SV and CV, and from that we can calculate the SPI and the CPI. Now both the CPI and the SPI are less than 1, which isn't good. It means we're likely to have schedule and cost overruns. What can cause variations? Why do we run over budget? Many reasons. Changes in spec, changing in time frame schedules, financial things, inadequate project objectives, buying on lowest price. We could have unforeseen problems which could cause us to spend more than we'd planned. There can be a whole host of reasons that cause variations. And just to refresh your terminology, if you aren't very clear on earned value is using budgets. The difference between a budgeted figure and an actual figure is known as variance. So at a very simple level you can say variance analysis can be used to monitor and control projects, but if you can discuss earned value you're going to get more. And here's the only exam question that's ever been asked on earned value, which is hot for the exams, and that is explain a tool such as earned value that can be used to monitor the spend. 13 marks. And as you can see, the answer doesn't go into the mathematics, It's more that you understand the principles. So candidates should refer to the methodology. It's essentially a control system where the project is monitored, so the actual work and the completed value is assessed to see if it's on track. And earned value shows how much of the budget and time should have been spent with regards to the work done to date. Earned value integrates cost, schedule and scope and can be used to forecast future performance by calculating the CPI and the SPI and completion dates. It is an early warning project management tool, and it aims to achieve projects that are on time and on budget. So it needs the cost of work partially done to be quantified, so we can then compare how much work has been completed against how much needs to be, and the project manager should initially agree the project scope, create a work breakdown structure and assign a budget to each package, and then a schedule should be showing the time it should take to complete the work. The overall plan is baselined, that is the planned value at certain dates, and used to measure performance throughout the project, and as each package is completed it is compared with the planned value, and a variance to the plan is recorded. So in a nutshell, this slide gives you the typical answer about earned value. Three main causes of financial variation, which just expand on the slide we looked at earlier: changes in specifications, schedules, problems, poor objectives, buying on price, adverse weather maybe, specifications not clearly defined, poor coordination, etc. etc. So we're very quickly on to 4.3, which is a little more technical, and this is about how supply chain issues can impact projects. So it's basically if suppliers let you down, what can we do about it? If there's problems with the condition of the equipment or the building that you've purchased, or if they aren't turning up on site, or we've got problems, then we need to address this. So what are remedial actions? We need the contractor to provide an early warning of an event that could cause the contract price to increase or a delay. We might need to instruct the contractor to attend a risk reduction meeting. We might need to notify the contractor if there are inconsistencies with their specification and documentation. We need to approve the contractor design and the use of subcontractors. That helps prevent problems and risks in the project. We need to approve the contractor's programme of work before they can start. And we need to stop or not to start any of the work. And you can see there's more actions there on the right hand side. So a whole list of remedial actions. We may be involved in dispute resolution, and we can use the ADR, alternative dispute resolution methods. Strictly all these aren't alternative, they're the full list of dispute resolution, going from the softly negotiation right through to the expensive litigation, and possibly more and more now people are using mediation. It's a less costly and a more friendly way of resolving disputes. Consequential losses and damages can be made. So for you to be able to claim damages, the breach must have caused the loss was foreseeable, you can evaluate the damages reasonably accurately, and the claimant is not claiming for a loss which they could have avoided. So you can get consequential damages providing that's in place. Another way is to actually agree the damages before, in which case we'd call them liquidated, and an option clause X7 refers to delay damages, and often service credits are used as a form of liquidated damages in the IT sector, using this principle to deduct monies for inefficiencies. So you might agree a liquidated damages clause where there's so many £1,000 worth of damages, say for every day the project's late, up to a maximum of 14 or 20 days perhaps, otherwise the term would become a penalty clause. Penalties. A clause will be held to a penalty if the sum is extravagant, it's more than the loss. The clause consists of paying a single lump money on the occurrence of one or more of a range of events, and the clause is imposed by the purchaser once the contract is underway. So it may not be called a penalty clause, but if it doesn't meet these conditions, it will be illegal and wouldn't be enforceable. Contract warranties and conditions. So conditions go to the heart of the contract, and if a condition is breached, the contract can be void, voidable or rescinded. Whereas if it's simply a warranty, the wrong party will only be able to seek damages for any losses, and the contract is still binding. So you can't cancel a contract for a minor misdemeanour, which is more of a warranty than a condition. We might ask for specific performance as part of a remedy, where they're actually enforced to carry out their contractual duties. So it's an alternative. Under such action, the courts will compel a party to execute a contract according to the terms in the contract, or alternatively to execute a substantial part of the contract, so justice will be done. Termination in the NEC contract, which is a good contract to have a knowledge about. The employer may terminate if the project manager has notified that the contractor has defaulted in one of the following ways and not put the default right within 4 weeks: failed to comply with his obligations, not providing a bond or guarantee which this contract requires, or appointing a subcontractor for much of the work before the project manager has accepted the subcontractor. That would allow you to terminate the project. And the usual sort of examples: force majeure, if it goes on long enough the contract could become frustrated. If the subject matter has been destroyed or an event is not going to happen anymore, the contract just becomes frustrated. There can be quality issues on contracts where you might reject. There might be rework involved, and compromised. If the project team accepts work that is below the agreed standard, then this will be classified as compromised. So 3 quality issues there. Stages of a project: plan, build, defect liability period, end of lifetime period. So you've got 5 stages and 4 intermediary phases. And finally, we're on to the closing the project out, getting the client to accept it, closing it at the project out, and gleaming the knowledge to feed into future contracts. So when we're measuring performance, we can measure against time, and there's some good indicators there. Cost, quality, number of defects, health and safety, accidents, client satisfaction. So they're all measures we can use to assess whether the project's succeeded. The audit will be looking at the efficiency of the project, the impact on the customer, and the benefits on the business, the direct contribution the project has made to the business objectives. An audit template might look something like this: general introduction and the current status of the project against cost, schedule, progress, quality, some assessment of future project status, management issues, and a section on risk management. So this is a typical template. How do we do an audit? Assemble a small team, familiarise them with the project, audit it, debrief, written report, distribute the report, and follow up to see if the recommendations have been implemented. Knowledge can be developed in a project. Some knowledge is clearly written down, it's formal, it's easily communicated, such as books, reports, but some knowledge is tacit, it's in people's heads, it's difficult to communicate, it's like a black box. And Nanonka and Taguchi came up with this famous SECI model: socialisation, externalisation, combination, internalisation, hence why it's called SECI, S-E-C-I, which basically shows how tacit knowledge can be changed into explicit knowledge. So we've got there tacit to explicit, combination of explicit to explicit, and moving round internalisation, and then finally socialisation. So it's quite a complex model. There's a couple of good video clips on my extended videos, on the recommended videos. The model is not named on the unit content, but the concept of learning and passing knowledge on is important, obviously, in project management. So there's a more detail on the SECI model. How do we do, what is socialisation, what is externalisation, etc. What are typical problems in real life to learning? And this is from government departments: lack of senior manager endorsement, silo structures, stopping knowledge being shared, poor processes, mechanisms, high workforce turnover, the learning, the experience is lost, and lack of time due to high workload and management prioritising shortcomings. Dealing with conflict is obviously a big part of project management, and don't forget, of course, our friend Thomas Kilman. But in a general terms, we can encourage openness, set a role model, demonstrate an attitude that conflict should be harnessed to achieve positive outcomes, and confront the conflicts that exist rather than shying away from them. And I think so that's fairly typical answer there on that. And that's the content. Sorry, that slide should be one back. That's the bottom of the answer. Project tracking and control mechanisms, work breakdown structures, control processes, earned value, which we've discussed. That's always a good part of any answer on this section. Use of critical path analysis, controlling variations, and NEC uses early warning notices. So this is an information system